All right, this is Molecular Geometry by Mindy Bedrosian, and here's a cool geometrical shape. Stare at that for a while. Makes your eyes go dizzy. It's cool, isn't it? All right, this whole section here is devoted to hybridization. Hybridization is when atoms combine their electron clouds. They get a new electron cloud. It's a new shape. It's a new energy level. It's a combination. They combine to form new shapes. The example we're going to look at is methane. If you remember, CH4 is the formula for methane. And if we drew it on a piece of paper two-dimensionally, it looks like this, which is not a good representation of it three-dimensionally. Three-dimensionally, we'll use a ball and stick model, and you can see that the angles are not 90 degrees apart like they are in the picture, in the drawing. They are 109.5 degrees apart. We can show this as a drawing. The dotted means that hydrogen's in the back. The thick one means that hydrogen is in the front. You can kind of see it matches better. And this shows the electron clouds, the new clouds that are formed from their bonding. This is called sp3, this kind of sharing. And it's pointing to that electron cloud. So when hybridization occurs, of course, there's always things having to do with energy. There is a change in energy. If we look at the free atom, we will know that we have 2s and 2p. These are the energy levels, how far they are from the nucleus. 2s is less in energy because it's closer to the nucleus than 2p. However, when hybridization occurs, you get one new bonding cloud. And this actually settles sort of in the middle of those energy-wise. So this is called sp3, and you can see energy-wise, it's in the middle of the 2s and 2p. This picture you will find in the book. It's talking about effective electron domains. Those that are possible can possibly bond with something else. The electron clouds with two electrons are called electron domains. And they become bonding domains if they're bonding with something else, non-bonding if they don't. So for the first example, we are looking at CO2. The bonding domains are the electric clouds that are actually used to form bonds. Since it's using all the bonding domains, it has no non-bonding domains or unshared pairs of electrons. Tetrahedral shape is using all four, as you can see. It's for methane, it's going to use all four. All four will be bonded with hydrogen. So there's no unshared pairs of electrons. So that's a 0. We can only bond with 3, and having one domain empty or unshared, that would give us ammonia, NH3. And you can even do water with 2 unshared pairs of electrons. This is another way of looking at it. This is the bond angles. They're showing you the angles and the electron pair geometry as well. You can take a look at that tetrahedral. And then there are those that can accept more than 8 electrons in their outermost shells, if you remember from last chapter. So effective electron pairs around an atom, arrangement, and the hybridization, what it is considered to be hybridized. If there are 2 pairs around an atom, the arrangement is linear, and that is called an sp hybridization. If there are 3 electron pairs around the atom, this is trigonal planar, and it is sp2. If there are 4 effective pairs around an atom, this is tetrahedral like methane, and that is hybridization sp3. If there are 5, it is trigonal bipyramidal. And that is sp3d. These are things you did not learn last year. And you can even have 6. Remember, these are things that can accept more than 8. This is octahedral, and this is sp3d2. So let's look at a few examples. This is trigonal planar. That's BF3sp2. There is carbon dioxide. That is just sp, CO2. hopefully here's methane. CH4sp3, this is tetrahedral. Now, if it doesn't use all of them to bond with, then we get something like this, NH3, and that's a little electron cloud there. It's trigonal pyramidal, sp3 bonding, hybridization. If two clouds, we get bent or angular, this is water. And this is still sp3, same as methane. Trigonal bipyramidal, PCl5, is sp3d. And seesaw, SF4, one of those clouds is unshared. And here, two of the clouds are unshared. You get a T-shaped. And three of those clouds are unshared. These are all sp3d. And then the last one is the octahedral. And that is sp3d2. So, bonds formed from the overlap of orbitals between two atoms, so it's what's right in the middle between two atoms, are called sigma bonds. We can't fit all the electrons they share in between them, so some are shared above and below. Bonds formed above and below the center plane are called pi bonds. So a single bond is a sigma bond. This is on the plane. This is the area shared between two atoms. A double bond is a sigma and a pi. So what's shared between and then above, below. And one pi bond. Can you guess what a triple bond must be? A triple bond consists of one sigma and two pi. The other pi's are side to side on the outside. Up and down, side to side. And to finish this off, let's look at a cool geometrical shape here. This is geometry. If you stare at one, it looks like the other's rotating, and vice versa. If you stare at the other, then the other one rotates. Cool!